Welcome to Coach Eichner's Math. Today we're going to talk about trapezoids. We have already talked about some quadrilaterals. So on our quadrilaterals that we've talked about, we know that parallelograms make up the majority of what we discuss. Okay, and under parallelograms, we have rectangles, squares, see if I can spell squares, and rhombi. Those are all underneath parallelograms. We're going to talk today about trapezoids. So right now, all of my rules that work for parallelograms work for rectangles and squares and rhombi. However, the parallelogram rules do not apply for a trapezoid. So make sure that we're real careful as we're setting up here. Trapezoids are going to have some different properties about them. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So I'm going to draw parallel sides. I'm going to go ahead and draw a line out like this and out like this. This is what we're used to looking at when we talk about trapezoids. Okay, and we'll talk about specifically what kind of trapezoid that is here in just a little bit. Zoom out for you so you can see me. The bases. When I'm drawing, the bases are the parallel pieces. So the bases are the bottom and the top right now because they are parallel. I could also turn it and have the same look the other way. Same time, my legs are the two pieces that are not parallel. Okay, so the legs are not parallel to each other. And then finally talking about the base angles. So the base angles are the angles at the bases. So if I'm talking about the base angles in relationship to this base, we would talk about the base angles here. If I'm talking about the base angles in relationship to this base, it would be this and this. Notice I marked them as congruent. They are only congruent in this specific type of triangle or specific type of trapezoid I just drew, which is an isosceles trapezoid. We will talk about that more here in just a couple of minutes. Looking down below, example number 1, find the value of x for the trapezoid. So let's see if I extend my lines out. I know I've got parallel lines. Anytime I have parallel lines, I'm going to extend my lines out and I'm going to look at it. And I'm going to do my zigzag or my Harry Potter and decide that these 4 angles must be congruent. So the 4 red marked angles are congruent. I have one that's marked, one that's not. So those would be same side interior angles. So what you know about same side interior angles, they're not congruent, so they must be supplementary. So we can say 25x plus 5 equals 180. Or 25x equals 175. X must be 7. All right, so we can always use our parallel line rules when we're talking about different pieces. The next thing we're going to talk about is the median, a segment that joins the midpoints of the legs of a trapezoid. So I'm going to draw a different type of trapezoid. We'll make it look like the one we just looked at. If it's going from midpoint to midpoint, we call it a median. Okay? To find the length of a median, we use the following formula. We say base 1 plus base 2 divided by 2. So I average the bases to find my median. Looking over the next page. Example number 2. They're going to give us a bunch of problems here back to back. Trapezoid, EF is the median. That tells me that those 2 pieces must be congruent. Those 2 pieces must be congruent. That means that's parallel to that. So let's look at it. AB is 25. DC is 13. So base, we're going to call this base 1 and this base 2. So this is base 1. And this is base 2. 25 plus 13 is 38. Divided by 2, which tells me that EF is 19. AE is 11. FB is 8. Well, we already marked them as congruent, so if AE is 11, ED would be 11, so AD, the whole thing, would be 11 times 2, which is 22. If FB is 8, FB and CF are the same, so 2 times 8 would give me 16. Looking on at example C, AB is 29, AB is 29, and EF is 24. Find DC. So the hard way to do this would be to write out the equation we found out. What I'm going to do is I'm going to say that base 1 is x. I'm going to say that the median is 24. And I'm going to say that base 2 is 29. How did I get from base 2 to the median? I said minus 5. So how would I get from the median to the other base? I would again have to say minus 5 because it is the average. It's in the middle of those two pieces. So base 1 would be 19. 24 minus 5. Looking down at D. AB is 2y plus 6. EF is 5y minus 3. And DC is y minus 2. Okay. Let me go ahead and get a different color because we're going to need to write these out. AB is 7y plus 6. EF is 5y minus 3. And DC is y minus 2. Now, nothing has changed. B1, we're going to say y minus 2 plus 7y plus 6 equals 5y minus 3. Now, the one thing I forgot to do is divide by 2. So I'm going to first put my like terms together and say 8y plus 4 divided by 2 equals 5y minus 3. Right now, that 2 is easy to divide into both. So I'm going to say 4y plus 2 equals 5y minus 3. Subtract 4y from both sides, leave me with y. Add 3 to both sides, which leaves me with 5. So y must be 5. And finally, the last part of this, we're going to say the measure of angle, EAB. EAB. This angle right here is 63 degrees. Find the measure of DEF. Well, we know that these lines are parallel. So if EAB is 63, DEF must also be 63 degrees because they are corresponding angles. That just goes back to our parallel line conjecture. Looking at example number 3, find the value of x for the trapezoid. This is real plain and simple. Base 1 plus base 2 divided by 2 equals the median. So 24 plus 34 divided by 2 equals the median, or 58 divided by 2, which is 29. Just like that, that easy. So, properties of a trapezoid. Exactly one side parallel. So we've got one pair of parallel sides. It will always work out that the median in the middle is also parallel to the bases. And number 2, the median is half of the bases. Remember, it's the median because it is the midpoint and midpoint of my two legs. Looking on, we're going to talk a little bit about isosceles trapezoids next. At this time, I'm going to go ahead and switch over videos. Please go find the second half of this video, which is isosceles trapezoids. This has been Coach Eichner's Math. Hope you're having a good day.